All right, we talked the other day about derivatives. So what did we say the derivative tells us? We said that on any line you have, the derivative tells you the slope anywhere on that line. If I want to know it right at that point, the derivative, if I want to zoom in a million times, I could figure out the slope between that. If I zoomed in a million times, it would look like a straight line. So what we're talking about, as I say, it's the magical equation that tells you the slope at any point on that line. Technically, it has given us the slope of the line that is tangent at that point. We have a point and we know the slope. Well, we can actually give the equation of that tangent line. So if I have this line and I have the equation of it, I take the derivative. That derivative tells me the slope anywhere I want on it. All I got to do is plug in the x value. So let's say that I want it right here. I can find the slope right at that point, which is basically the slope of that tangent line. Well, I have a point and I know the slope. I can use y minus y sub 1, slope, x minus x sub 1 to find the equation of that tangent line. That's what I can do. So let's think about it. It says give the equation of the line that is tangent to f of x, blah, 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 at 0.15. So what you have in x cubed is sort of coming in here and doing this. You and I want to go to this point right here. Let's say it's 1 at 1.5. And we want to find the slope of that tangent line, but a little bit more this time. We want the equation of that line. I want to know the equation. I can find the slope of it because I know I'm looking at that point right there at 1.5. The derivative will tell me the slope at that point. And then I have the ordered pair, so I can use the y minus. So let's do it. Let's see. The derivative of the function, which again, the derivative is the magical equation that tells you the slope anywhere on the line, is 3x squared plus 4x plus 3. That right there will tell me the slope anywhere I want on this line. Well, I want it right here at 1.5 when x is 1. So I'm just going to plug in 1, and that'll tell me the slope. 3 times 1 squared plus 4 times 1 plus 3. So it's 3 plus 4, 7, 10. That guy has a slope of 10. Extremely steep right there. Okay, it's like, woo, almost straight line. So it has a slope of 10. So we know we have a slope of 10, and we have a point. That blue line is crossing that 0.15, isn't it? Yeah. So y minus y sub 1, slope, x minus x sub 1. Because I have an x sub 1 and a y sub 1. So y minus 5, slope is 10, x minus 1. Let's scroll our screen down a bit. So y minus 5, 10x minus 10. Move my 5 over, and you and I have the equation of that tangent line. Okay, so we're asking a little bit more than yesterday where we wanted the slope. We want the actual equation of it. So let's do it one more time. Give the equation of the line that is tangent. Now again, I want you to understand an x cubed usually comes down and goes like this. We're looking right here at the point 214. Okay, there's our point 214. We want to zoom in a million times or basically find the slope of that tangent line. So we want to know, hey, what's the slope? Well, the derivative tells us the slope. So we take the derivative, 3x squared plus 2x plus 1. That equation right there tells you the slope anywhere on the black line. Well, we want to know when it's 2. So 3 times 2 squared plus 2 times 2 plus 1. So 3 times 4 plus 1. So 12 and 4, 16, 17. Superman slope. Okay, slope of 17. It's huge. Well, let's just plug it in because we want the equation of the line. We know the slope. We actually know one point that's on that blue line. That's the point 214. That point is on the black line and on the blue line. Y minus, the y value is 14. Slope 17 and 2. So just finish it out. Distribute through. That's 34. I think we have enough room. I'll do it right here. Y equals 17x minus 20. That is the equation of that tangent line. Now, we want to look at a few other concepts. We want to talk about special points on a line, and there's a maximum, a minimum, and a point of inflection. Okay. Now, what are those? Well, minimum and maximum we can find pretty easily. On this line, it looks like it comes and slides down. Right here would sort of be a minimum. Right here is a curve where it'd be a maximum. Now, it's called a relative minimum and a relative maximum because technically this line's going up forever and down forever, so it never really has a complete minimum or maximum, but is a relative. In other words, for this little section, it is the lowest point. And for this little section here, it's the highest point. Now, what is this point of inflection? Well, notice this curve is bending this direction, and at some point it starts flipping the other way, which is about right here. That's called a point of inflection. It's where the curve is going one way and then it starts going the other way. This one, notice again, it's sliding up, 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 and then it starts coming more down right there. That's what's called the point of inflection. Okay, so consider these three possibilities if you and I are talking points. Now, what I want is, let's say that on a number line, we have 3 points. I have a point here, and then the next point when I plot it is here, and then the next one is here. Well, if I'm looking at that, obviously what would that point right there be? The middle point. We're looking at what the middle point would be. Well, in that case, it's obviously what? A maximum. The other possibility, I said there's 3. You could be here, and then it could be here, and then the next guy's here. Well, then what was that point? He was at the lowest point, so he was a minimum. And the final possibility, a point here, and then another point even lower, and then it's just what? It's going down. Now, if we say that's a critical point, we know that had to be the point of inflection. So either your point, the middle point, is at the highest, maximum, lowest between the 2 points, minimum, or it's in the middle. The guy to the left is higher, lower, and same on the right, and therefore it is a point of inflection. In other words, if it's not a maximum or minimum, it's got to be a point of inflection. So let's say that I said, hey, when I plugged in 4.9 into the equation, I got 6.2. When I plugged in 5, I got 6.4. When I plugged in 5.1, I got 6.2. Well, if you just think about it, here's 4.9, here's 5, here's 5.1. I had a height of 6.2. The next one was higher at 6.4, then it was back lower at 6.2. So what is that middle point? It is obviously a maximum. It's that simple. Let's do one more here. So again, you have a point at 4.9. We plug in for the x, we plug in a 5 for the x, and we plug in 5.1. You had 6.2, 6.4, so it's higher, and then 6.5, higher again. So that point, if we tell you it's critical, it obviously isn't a maximum. It's not a minimum. That means it was a what? Point of inflection. All right. Hopefully all that makes sense. I know it was a lot to sort of digest. Go back and watch again if you need to.